And welcome to the Daily Space Weather. We're starting things out looking at sunspot 2814 here, a beta class sunspot, raising the probability for significant solar flares. It's grown in the past couple of days. Produced a couple B class solar flares. Again, likelihood of additional solar flares continues. Likelihood of Earth-facing coronal mass ejections now very low. And we've got some non-Earth-facing coronal mass ejections to show you. First, a close-up of the magnetic fields associated with sunspot 2814. I apologize if yesterday I was calling it 2815. I had the wrong number. 2814. So there's a close-up of the magnetic fields. And we've got opposite polarity umbrae there indicating it's a beta-class sunspot. Let's take a look at the view from Lagrange point 5, the location of stereo A. And here's what's been going on out there. Coronal mass ejections on the far side of the sun. A little bit of ejecta on the Earth-facing vicinity as well. Those look like they'll miss to the north. And from the perspective of stereo A, Earth is out to the right, so Earth would be out in this direction. Close to the equator of the sun, around where that purple arrow points. So some fairly spectacular coronal mass ejections there, and the far side coronal mass ejections may continue. Here's the view from the LASCO C2. Now this is located at Lagrange point 1 on the SOHO spacecraft. And you can see that non-Earth-facing coronal mass ejection. Very bubble-like appearance to it there. And let's check out the LASCO SOHO C3 as well. And you can see Mercury coming into view on the right side of your screen there as well. Venus on the left side of the screen. Great view of the propagation of that far side coronal mass ejection. Here's another full disk view from the SDO, the Solar Dynamics Observatory. And again, there are still a bunch of filaments around the limbs. You can see filaments down here, up here. We'll show you an animation of that later. Here's a close-up of the southeastern limb. We've got some even more close-up views of sunspot 2814, as well as the coronal holes on both sides of it. You can see a leading coronal hole and a trailing coronal hole. They're South Pole oriented coronal hole regions. Great view of those in 193 angstroms. A close-up of sunspot 2814 in that same wavelength. And some minor flaring associated with that as well. Here's a diagram of the solar system. And there's where things will be in a week. And here's a star chart. If you're up before dawn, you may see Saturn and Jupiter rising ahead of the sun. If you've got a clear sky and a view of the ecliptic, there's Saturn having already risen where I'm located. If you want to make yourself a star chart, check out in-the-sky.org. The 10.7 centimeter radial flux has suddenly jumped up to 83. No real surprise there as we see a significant sunspot group. Here is the 10.7 centimeter radial flux over 1 year. As reported by Solar.info, this black line is the radial flux, again now at 83. And this red line down here is the sunspot number. We saw an uptick in that as well, and you can see how proportional the sunspot number is to the radial flux. It's 2,800 megahertz. And let's talk volcanoes. La Soufrière has caused some huge explosions, pyroclastic flows, possibly causing in some death and destruction, as Saint Vincent evacuates and The Caribbean island of St. Vincent has a significant volcano, La Soufriere, and it has fired an enormous amount of ash and hot gas, pyroclastic flows, etc. Not the best scenario for that island. It's destroying everything in its path, says Urosila Joseph, director of the University of the West Indies Seismic Research Center, told the Associated Press. Anybody who would have not heeded the evacuation, they need to get out immediately. And this is all over the newswire. Issues with water being tainted by the volcanic ash and so on. And this is a phys.org article located in their Earth section. St. Vincent needing some water distribution and so on. And there's an image of one of the explosive volcanic ash plumes. So volcanic ash raining down in the Caribbean. And let's see what else has been erupting. Mount Abico, 12,000-foot ash plume there. Sakurajima, 7,000-foot ash plume there. Cinnabung, 12,000-foot ash plume, 19,000-foot ash plume over Popocatépetl. Fuego, no volcanic ash emissions observed. Please do not pole vault the caldera. Sangay exploding, 27,000-foot ash plume in Ecuador. Sabancaya exploding, 24,000-foot ash plume in Peru. So major eruption there, a 44,000-foot ash plume. Close to stratospheric levels there, folks, despite being so far south. 44,000-foot ash plume quite close to the troposphere-stratosphere boundary. We could have some ash and gas ending up in the stratosphere that could stay there for years. In any case, that's the report. Another reminder to not pole vault the caldera. Here at smAsho and the Smash News Network, least busted name in news, we prefer for our viewers to remain healthful. That public service message by smAsho. Earthquakes look very light over the past 24 hours. A surprisingly low number of earthquakes here. No major ones. A 5.1 near Japan. A 5.2 near the Loyalty Islands, which are located in Oceania there, north of New Zealand. A deep quake on the North Island at a 4.3 magnitude. A deep quake at Afghanistan. And a 5.1 at Ascension Island. Very low number of earthquakes reported here over the past 24. And here's the GOES X-ray flux. You can see those two minor B-class solar flare incidents happening yesterday and early this morning. Here's the proton flux over the past 3 days. No strikes there. The coronal mass ejection strike was a glancing blow at best. Here's the GOES magnetometer over the past 3 days, and we'll look at some more magnetic data now. It's the heliospheric current sheet in terms of polarity, and you can see how the Earth is in a South Pole-oriented current sheet. We're not expecting that to change anytime soon. Here's a line of sight coronal hole plot, and you can see that large coronal hole moving into the Earth-facing zone. It's actually sort of a double there, and it's got a sunspot in between those two coronal holes. You can see there South Pole-oriented red coronal holes in the southern hemisphere. As the solar polar field reversal process is taking quite a long time to really kick into high gear here. So here's the line of sight ecliptic plane field plot. This shows you essentially a three-dimensional potential field surface source line view of the current sheet from the perspective of Earth, as well as the magnetogram. We like it. We're going to continue using it as a regular feature on the daily space weather videos. Now we're looking at filaments and sunspot groups. You can see sunspot 2814 there, as well as some filaments. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . And those filaments are mostly right on the eastern limb. The KP index, a measurement of global geomagnetism, is at 2 currently. And let's take a look at real-time solar wind here. And here's the coronal mass ejection strike, folks. It's quite a significant signature here. You can see the temperature dropped a little bit. The density dropped a little bit. And the speed came up a little bit. So it was a low-speed solar wind, a low-speed coronal mass ejection there, having only reached a maximum of not even 400 kilometers per second there at the end of the coronal mass ejection strike. And this is a sure signature here. You can see the speed jumped up and the density came down at the same moment. Actually over a period of a couple hours there. And then you can see it rather abruptly ends here with an increase in the temperature. You can see the temperature decreased during the small coronal mass ejection glancing blow sort of event. Current conditions have dropped back down to background levels pretty much. Current solar wind speed, 358 kilometers a second. Current solar wind density, just under 9 protons per cubic centimeter. Fantastic. Now, geospace magnetosphere movies. It's 4 hours of data. In terms of nanopascals, we're looking at magnetohydrodynamic pressure. And we see a fairly steady pressure here as we approach northern hemisphere summer and southern hemisphere winter. Here are ground magnetic perturbations. It's another form of geospace magnetosphere movies. Geospace delta B changes to the Earth's B field. And we show it daily due to the the current geomagnetic excursion that you're living through, folks. We've got 2 North Poles, one over Canada and one over Siberia. The South Pole has left the Antarctic continent and is someplace south of Australia. Did you know we have a Discord channel? You can find links to it at smAsho.com. Right over here, underneath this arrow, has all of our social media, and the permanent link to our Discord channel is there, so check that out if you like. And we'll be doing more with the Discord channel in the future. Welcome to the Neo-Renaissance. Visit our links. smAsho.com contains quite nearly all of them. We also regularly do stream live to Twitch, twitch.tv/smAsho. They've got a great mobile app as well. Thanks to our YouTube subscribers. Thanks to YouTube for allowing our subscriptions to be stagnated at either 1,740 or 1,750 for an extended period of time. I'm sure it's completely our fault that our subscriber count has been stagnated at either 1,740 or 1,750 subscribers for, I guess, like pushing 6 weeks now or something like that. YouTube.com/smAsho/playlists contains a bunch of playlists that have all kinds of different videos, not all associated with space weather, thanks to our new subscribers over at BitChute. And let's do a cosmology segment. Were you aware that there's an upper limit in terms of how fast brown dwarfs tend to rotate? Yeah, it's like 1 hour. And by the way, a planet the size of Jupiter rotating at a 1 hour rotation speed means the equatorial region is moving at like 100 kilometers per second. It's a Universe Today article. Yes, brown dwarfs. So the 2MASS, the infrared telescope, is tracking brown dwarfs, and we've noticed that it turns out that if they, perhaps the reason that they only spin at about a 1 hour rotation rate, in other words, a day only takes an hour on the fastest rotating brown dwarfs, perhaps it's because they would fly apart otherwise. So here's a small planetoid type object from our solar system here, Haumea, which has a rapid rotation, which makes it kind of pancake shaped. And so an interesting article here, again, it's universetoday.com if you want to check out this article. So brown dwarfs have a mass between about 13 and 78 Jupiters. And we use changes in the brightness to attempt to determine the length of their day. So they've studied over 2,800 of them. And for 78 of them, we know their rotation speeds. Since the cloud layer has weather features like Jupiter, so the periodicity of the brightness tells us their rotation rate. Again, if it has a 1 hour day, the equator on some of these brown dwarfs are rotating at more than 100 kilometers per second. So it's not entirely clear why that seems to be the upper limit to the rotation speed, but perhaps it is because they wouldn't exist. Now let's talk about lofar real quick. If you'd like to send lofar a request, you need to head to old.astron.nl. If you head to old.astron.nl, hover over Radio Observatory, come down here to Observing with LOFAR, and click on Observing Proposals. That will give you the procedure for requesting that the massive radio telescope located in Europe fix its gaze upon an object you'd like, which we'll be actually doing. So we emailed them, and today we won't be talking about anything random. How about black holes? Now, I've been referring to them as massive radio sources since the mid-90s. Back in the day when astronomers told me that radio astronomy is the future of astronomy, I'm not sure if I believed them, but in any case, are black holes gaining or losing mass? Ultimately, the answer is, folks, that we do not know. So we do see a relationship between their torus and their poloids, and I won't get any more in-depth into that, but this article is located at phys.org in the Astronomy and Space section. And we'll take this as a quick moment to take a look at one of the most famous massive radio sources, probably the most famous one, M87. Now, what's interesting about M87 is that there's a jet, a collimated jet of material. You can see it right here. And it's directed toward you, sort of. Not directly toward you, so it's a great opportunity to see the jet. And indeed, it looks like train cars, folks. So let's zoom way in. You can see the way it looks. It's connected by these narrow filaments, and then it's got these more expansive regions in the jet as it propagates out from galaxy M87. Now one of the most famous galaxies in the universe, M87. Leave a comment if you think black holes are gaining or losing mass. Ultimately, the answer is, folks, we don't know if the sun is gaining or losing mass, or if the galaxy is gaining or losing mass. It's just not known because it's impossible to measure. And that's today's cosmology segment. Let's continue on here with some information about electrons. So the Earth is surrounded by electrons, as well as a soup of other ionized particles in Earth's plasmasphere. Here are the relativistic electron flux over the past 1 year, as reported by Solon.info. Here's the 3-day chart, and we're seeing quite low levels of electron flux continuing here, as solar minimum conditions have sort of come to an end again here with this new uptick in the radio flux and a significant sunspot in the southern hemisphere. Here's the electron flux forecast model, and the forecast is for flatlined electron flux over the next few days. There will be a coronal hole wind stream on the way. We'll be reporting on that in a day or two. Here's a diagram of the Van Allen belts and so on. Feel free to pause the video. Here's a visualization of the total electron content forecast. This is showing you the whole air column from a GPS satellite down to your handset. And when we see low levels of electron flux, we're more likely to see anomalies around the equator at nighttime. The most GPS errors occur around the equator at noon. Here's another diagram of the atmosphere. This one's got distances in kilometers. And this red F here is the F ionosphere layer, which is what we're showing you next. So here's the vibrational frequency of the portion of the atmosphere at about 300 kilometers, the ionosphere map as reported by Bureau of Meteorology of the Australian government. And we're seeing some anomalous features here. So we're seeing some rapid charge ups in the daytime, some rapid charge downs in the nighttime. You can see those large red bulges form there. That's the F layer when it breaks all the way down to 1 megahertz. only 1 million vibrations per second. And each little tick of the clock here is showing you 15 minutes, a 15-minute time progression, and a snapshot of that time. Let's bring up the latest image here coming through at 8:15 Universal Time. Next, looking at surface winds. Here are the surface winds of the eastern world. And this cyclonic system has now moved down to the south of Australia. And actually, there's a large anticyclone down here now. You see this counterclockwise rotation. That's an anticyclone now off of the west coast of Australia. Let's look at the jet streams. Here are the jet streams of the eastern world. Quite chaotic. And we see some reversed jet stream here over places like Indonesia. Here are the jet streams of the western world. Powerful low pressure system here over South America, as well as very chaotic jet stream flows here over places like Canada. Quite chaotic. And here are the surface winds. We've got some anomalous winds up there in the North Atlantic. You can see areas of extreme calm. Some placid waters up there, perhaps. And let's continue on with meteorology stuff. Here are the pressure cells currently on planet Earth. We'll advance this into tomorrow. There's where we expect them to be according to the GFS forecast at 1 p.m. Eastern Time. And if you're wondering about how I learned about meteorology, well, I'm what you call a self-taught meteorologist. I'm somebody who's taken a physics class. And let me tell you, that helps. So as a cyclist, I actually realized that I wanted to be very good at forecasting the weather in very precise fashion. And that's part of my meteorology background, folks. Learning the science. So here's our real-time lightning map. Looking at lightningmaps.org here. And we see some terrestrial lightning over Texas. Hey, Dallas. There's thunder rolling in Arlington, Fort Worth. And if you caught any imagery of severe thunderstorms and the areas above the cloud tops, leave us a comment. We'll feature it on the video. Here's a U.S. Doppler radar map, and this powerful low-pressure system is still hanging out over the northern Wisconsin area there. The western tip of Lake Superior is around where that low is located, right about here. Some pretty strong storms there over Texas. You can see small patches of red featured there. Here's the cloud layer. It's too dark to see the clouds. We use the shortwave radiation map of 3.9 nanometers. Here's the water vapor map. And you can see some massive pressure gradients there over Texas. A mixture of dry and moist air, and actually hot air, causing some sudden cloud nucleation. And you can see that happening there on the cloud map. And let's get into bonus features. Here at the Smash News Network, least busted name in news, we enjoy bonus features. And today's bonus feature, we'll start out with the current hydrogen alpha imagery at El Teide, Spain. There's the view. You can see sunspot 2814 there, that bright region, as well as some dark filamentary regions. You can see this filament here actually looks like it actually moved or collapsed or perhaps even ejected. And you can see filaments around the eastern limb as well, as we cited earlier in the video. Check out smashomash.com/forum if you haven't. If you'd like to win a free month of May's Patreon at the $3 per month tier, there's a contest. go check it out. Thanks to the smash team. Please don't forget to like, share, etc. Thanks to our patrons for increasing the probability that these videos will continue to exist. Patreon.com/smashomash. If you'd like the most recent alerts, etc., please consider becoming a patron. So here's what Sunspot 2814 looked like as I did show prep. There's the intensity gram, and there is the colorized magnetogram. Great view of that in high res, and that's why it's a beta class sunspot. We've got leading south pole umbra, trailing north pole umbra, which increases the likelihood of solar flares. Here's a full disk view in 171 angstroms, crowd favorite, and my favorite wavelength. We've got some more close-ups for you here. Here's a close-up in 94 angstroms. And this should show you some great temporal resolution of the minor solar flares that happened. Give it a moment to initialize, folks. Here we go. And you can see those brightening events. The second one was a double spike, so you get a great view of that. The 94 angstroms wavelength takes 10 images per minute instead of 2 images per minute, along with 131 angstroms, which we showed earlier. And here's some more imagery of Sunspot 2814 in 171 angstroms. Thanks for tuning in, folks. Remember, stare at the sun, attempt to understand the physics, don't drink, and if you do, don't drive. Welcome to the Neo-Renaissance. Visit our links. Welcome to the Neo-Renaissance. I'll repeat it. smAshomash.com. And since it'll never be now again, may that solar wind be at your back.